Hello all, welcome to my lecture 19 for the course EE216 Electrical Engineering for Applied Electronics and Instrumentation. Today's topic is on extension of range, ammeter and voltmeter, and this topic belongs to Module 6, Part 5. Myself Jayasri and I belong to the Department of Electrical and Electronics Engineering of Rajagiri School of Engineering and Technology. Now, the contents that will be discussed today: extension of range, especially for DC circuits, range extension of ammeters and voltmeters, a brief introduction, essential requirements for ammeters and voltmeters, shunts for DC circuits, and value of shunt resistance, multiplying factor we'll be discussing, and with regard to multipliers for DC circuits, the value of series resistance and multiplying factor, and finally you will have a summary also. Now, extension of range for DC circuits. For ammeters we will be using the shunts, and for voltmeters you will be using the multipliers. Now, range extension for ammeters and voltmeters. The operating principles of ammeters and voltmeters are, like you already studied, moving iron, PMMC and dynamometer type. Both are current operated devices. That is, the deflecting torque is produced when current flows through its operating coils. In an ammeter, you already seen, the deflecting torque is produced by the current to be measured or by a definite fraction of it. In a voltmeter, the deflecting torque is produced by the current proportional to the voltage to be measured. The real difference between the two instruments is in the magnitude of the currents producing the deflecting torque. Now, some essential requirements. The essential requirements of a measuring instrument is that its introduction into the circuit where measurements are to be made does not alter the circuit conditions and the power consumed by them. Very important point. Now, you know an ammeter has a low resistance and same is connected in series with the circuit whose current is to be measured. Current measuring instruments are connected in series, and a voltmeter has a high resistance and same is connected in parallel with the circuit whose voltage is to be measured. So, voltage measuring instruments are connected in parallel. That is, an ammeter can be converted into a voltmeter by connecting a high resistance in series with it. So, let us first see shunts as applied to DC circuits. A basic DC ammeter consists of a coil which is having a very low resistance. So, if a high value of current needs to be measured, what has to be done? The excess current, that is the current above the capacity of the ammeter, has to be bypassed. The bypass or the shunt resistor is connected across the ammeter. Please have a keen look at the diagram. This is my basic meter. A shunt is connected across. So, the total current gets divided into two. IM is the current flowing through the basic meter and ISH is the current flowing through the shunt resistor, and at any instant I is equal to ISH plus IM. We will come across it. Okay. Shunts are used for the extension of range for ammeters. A shunt is generally a low value resistance having minimum temperature coefficient and is connected in parallel with the ammeter whose range is to be extended. This combination is connected in series with the circuit whose current is to be measured. These shunted instruments can be used to measure currents many times greater than their normal FSD, full scale deflection currents. Very important. Now, let us see the expression for how to determine the value of the shunt resistance. Let Rm be the internal resistance of the meter coil, RSH the value of the shunt resistance which has to be computed, ISH the shunt current, IM is the full scale deflection current. So, total current we already seen, I is equal to IM plus ISH. As two resistances are connected in parallel, voltage drops across them will be same. Therefore, I can equate ISH into RSH is equal to IM into RM. Therefore, RSH is equal to IM RM divided by ISH. But you know ISH is I minus IM. So, substituting over here, I can get RSH is equal to IM RM divided by 1 minus Im. I can further simplify this. So let us assume the range multiplier. Let us take a new constant as m is equal to I divided by Im, which is called the range multiplier or the multiplying factor or the multiplying power. We'll see. So m is equal to I divided by Im. So on simplifying this, you will get RSH is equal to the value of shunt resistance is equal to Rm divided by m minus 1. Okay. Now we'll see the another alternate expression for multiplying factor. We already seen m is equal to I divided by Im. Since RSH is equal to Rm divided by m minus 1, m can otherwise be rewritten as m is equal to, cross multiplying and simplifying, you will be getting m is equal to 1 plus Rm divided by RSH. So we'll see the definition for multiplying power, or commonly known as a multiplying factor, or it can also be called as a range multiplier, and same is defined as, in the case of DC ammeter, we call it as a ratio between maximum current with shunt, so I, to the full scale deflection current without shunt. So it is Im. So it is m is equal to I divided by Im. Thus, to increase the range of ammeter m times, the shunt resistance required is, so look at this expression, shunt resistance required is 1 by m minus times the basic meter resistance. So this has been got from this one. Okay, equation number 1. Now we'll see with regard to voltmeter. For voltmeter we are using multipliers, and I have shown a diagram for DC circuits. A basic DC voltmeter consists of a coil having a high value of resistance, hence current flowing through it will be low. So to increase the range of the voltmeter to a high value, what can be done? A non-inductive resistance needs to be added in series with the voltmeter as shown in the figure, and that resistance is called the multiplier. So multipliers are used to extend the range of voltmeters. A very simple diagram has been shown to you. Now, in order to get the expression for series or multiplier resistance, let Rm be the internal resistance of the meter coil. Rs is the series multiplier resistance value. Im is the full scale deflection current. V, the full range voltage to be measured. This is the one to be measured. We are talking about DC voltmeter. So from figure 1, I can write V is equal to Im applying KVL. V is equal to ImRm plus ImRs, or ImRs, rewriting this one, you can get V minus ImRm, or the value of series or multiplier resistance can be calculated. On simplifying, you will be getting V minus ImRm divided by Im. So you will be getting Rs is equal to V by Im minus Rm. This is one expression. We'll have another expression also. We'll see it. Now let Vm be the voltage drop across the basic meter. It is the current flowing through that basic meter is Im, and its resistance is Rm. So Vm is equal to ImRm. Multiplying factor or multiplying power is defined with regard to DC voltmeter is defined as a ratio of full range voltage to voltage drop across the basic meter. So M can be defined as the ratio between V divided by, mathematically the same can be written as M is equal to V divided by Vm. This V divided by this voltage drop across the basic meter. Now substituting for V and Vm, you have already seen V, applying KVL, you have already seen V as ImRm plus ImRs, and Vm right now you have seen it as ImRm. Now on simplification you will be getting M, alternate expression for M as 1 plus, provided these two values are known to you. M is equal to 1 plus Rs divided by Rm. Now the value of the multiplier resistance can be obtained from equation 3. On simplification, you will be getting Rs is equal to M minus 1 times Rm. Thus, to increase the range of voltmeter, M times the series resistance required is M minus 1 times the basic resistance. So, making use of equation 4. So, you have seen Rs has got two equations. Rs is equal to V by Im minus Rm, and Rs is equal to M minus 1 times Rm. So, this is a fundamental equation. And M, the multiplying factor, is the ratio between V divided by Vm, and M can also be defined as M is equal to 1 plus Rs divided by Rm. So let me conclude this topic, extension of range of ammeters and voltmeters. We already studied moving coil, moving iron and dynamometer type. There are 4 common devices used for the extension of range of ammeter and voltmeter, namely shunts, multipliers, current transformers and potential transformers. But these two are mainly used for AC circuits. Shunts and multipliers are used to extend the range of PMMC ammeters and voltmeters respectively. Whereas in the case of moving iron ammeters, for the ranges up to 0 to 250 amps, shunts can be used, and for higher ranges, CTs are used mainly for AC circuits. And also in the case of moving iron voltmeters, for the ranges up to 0 to 750 volt, multipliers are used, and for ranges higher than that, potential transformers are used mainly for AC circuits. That is all regarding extension of range. And the reference books, Basic Electrical Engineering by D.C. Kulshetra, a course in electronic and electrical measurements and instrumentation by J.B. Gupta. Thank you. Have a good day.